This video is going to take you through AP Unit 3.6, which is sinusoidal function transformation. So now we're just going to focus a little bit more on these shifts on these, a vertical shift, a phase shift, which causes a horizontal dilation, stuff like that. So we're still working with our sinusoidal functions, which means we're still working with like our original parent function of sine or cosine. And we talked a little bit already about what a vertical shift or a vertical an amplitude change does. We talked a little bit about reflection, and we've talked about the period shift, but now we're going to actually work with it, and also with our vertical shift. So these are additive and multiplicative transformations of the sine and cosine functions. There's a lot happening now. You've got an amplitude change, and that could also have a reflection. B is going to cause a shift to our period, or how wide or narrow our graph is, how fast it makes its full complete cycle. The C is going to impact our starting place or our horizontal shift. We call that a phase shift. And D is our vertical shift. The same exact thing applies to cosine, except the original parent function is different. So a vertical translation is the first thing we're going to look at today, and that is if we add or subtract something after the function. So if there's parentheses, we're looking at after the parentheses. If it's a vertical shift, just like everything else, if it's positive, it's going to shift it up, and if it's negative, it's going to shift it down. This also shifts your midline. So if your midline was originally at 0 for your parent function, let's say the parent function of sine, if we shift our graph up 1 unit, then our midline is now at 1. If we shift it down 1 unit, then our midline is now at -1, or y equals 1 or y equals -1 specifically. Then we're going to look at a phase shift, and a phase shift again is what's happening inside the parentheses. This is a horizontal translation. So we're taking our function and we are shifting it to the right or to the left. And just like everything else with the parentheses and the horizontal translations, it's always the opposite direction. So if you add, you actually move it to the left. And if you subtract, you move it to the right. So what it says here is by negative c units. And that's what it means. If it was theta plus pi, let's say, then we're moving it negative pi. So we're shifting everything to the left pi. If it was theta minus pi, then we're shifting it to the right pi. So everything gets shifted to the right pi. All right, so let's look at an example here. Example 1 says to graph y equals sine of theta plus 2 and describe the vertical translation and then write the equation of the midline. So our vertical translation here is up 2, which means our midline that's normally at y equals 0 is at y equals 2. So you can either graph your original function and then shift everything up 2, or you could go straight into your shifted function. So I'm going to do both methods. If I was to graph my original function, this is sine, so we'd start at 0, we'd go up to 1, down to 0, down to -1, and back up to 1. So my graph would look like this. My midline would be at y equals 0. And then I can literally count up each of those coordinate points 2 places. So I can here, 1, 2 here, 1, 2 here, 1, 2 here, 1, 2 here, and then I can graph it. So you can graph the original, you can shift it, and then you can say that's what I want to be my answer. You can erase your original, or you can dive right into your answer or highlight it, whatever you want to do. If I was to graph this from scratch, then from the beginning, because it's sine, I would start at 0, up 2. So I'm going to start at 2. And then I would go up my amplitude, which is up 1 from here, back down my amplitude, down my amplitude again, and then back up my amplitude. And then I get that same curve. So whatever makes the most sense to you, you want to obviously stick to that method, but it's totally up to you. Both of those are fine. If you wanted to graph the midline, you would see it at y equals 2. All right, now we're dealing with a phase shift. Again, I know because it's inside the parentheses. So y equals cosine theta minus pi means we have a phase shift of positive pi over 4. So now where my normal coordinate points for our cosine, so this is a shift to the right, pi over 4. Where I normally would have 0, well, this is cosine. So I'd start at my amplitude. I'd start at 1. I'd come down to 0. I'd go to -1. I'd come back up to 0. And then I'd finish off at 2 pi. So my original curve a little sloppy, but there we go, a little bit better. That would be your curve. Now is shifted to the right pi over 4. So pi over 4 is halfway between 0 and 2 pi. That means pi over 4 is here. The increments of your points are still the same because your phase shift is still the same. So that pi over 2 now would shift to the right at 3 pi over 4. My point at pi would get shifted plus pi over 4, which would be 5 pi over 4. My 3 pi over 2 would get shifted to the right, pi over 4. I give that the like denominator, which is 12 pi over, nope, sorry, I'm going to multiply by 2. 6 pi over 4 plus pi over 4, which is 7 pi over 4. And that's a shift to the right, 7 pi over 4. And then 2 pi gets added that pi over 4. 2 pi is 8 pi over 4 plus pi over 4, and that's 9 pi over 4. So if you want exact points, and you don't always have to do that because you're graphing, sometimes it will just ask for the approximation. Sometimes you're doing this from a multiple choice graph, so it will be easier. But if you want exact points, then these are our new starting points. So instead of it starting at 0, it's starting at pi over 4. And then it's going to come down through 3 pi over 4. It's going to come down to 5 pi over 4. It's going to come back up 7 pi over 4. And it's going to finish off over 9 pi over 4. And that curve looks like this. This would drop down if it wanted to continue. Actually, it would be wider. It would be the negative pi over 4 there, because it's every half pi. And this would come back down. The other thing you can do is take your original graph. So if I was just doing an approximation, I'm going to erase this off again. My graph would have been 1. We said we would start at 0, 1, pi over 2, pi, 3 pi over 2, and 2 pi. And then I would take and shift everything over pi over 4. So in Notability, this is easy because I just shift everything over pi over 4. Because you can literally circle it and drag it. But obviously on your test, you're not going to be circling and dragging because you're not using your iPad. So you also want to be comfortable with that shift. Again, if you're looking for exact points, you would have to figure out pi over 4. I would add pi over 4 to each of those key points. If you're just trying to, connect, match it with a multiple choice question, you should be able to identify it by just figuring out where the start of that sine curve or cosine curve begins. All right, now we got multiplicative transformation. So where this would actually be a multiplicative transformation of sine and cosine curve is actually a vertical dilation. So think about it. Multiplicative means you're multiplying by something. Here we talked about this yesterday when we did our amplitude. This is just the stretch or shrink of our graph. This is a vertical dilation by a factor of the absolute value of A. So the amplitude change is always positive. You just take the absolute value of what's on the front of that, and that would be your vertical stretch or shrink. If it's bigger than 1, obviously it's a stretch. If it's in between 0 and 1, then it's a shrink. So that vertical dilation also changes your amplitude. Okay, example 3, and we had some of these like this in section 3.5. This is just your vertical stretch or your change in amplitude. It says to graph y equals 5 sine of theta, describe the vertical dilation. So because there's something being multiplied on the front of this, we know this is a vertical stretch. So this is a vertical dilation, specifically a stretch if it asks for it, by a factor of 5. The parent function is sine, so we start at 0. We're going to go up to 5. We're going to come back down to 0, down to -5, and back up to 0. There is one period of our function. If we wanted another period, we could just reflect it over the y-axis. The second multiplicative transformation is what happens when you multiply the actual theta or angle by a value. And this causes a horizontal dilation. So if I multiply theta by a number for either sine or cosine, it's going to cause a horizontal dilation or horizontal stretch or shrink. This time, like every other transformation that we use, if it happens inside the parentheses, it's actually caused by the reciprocal of, or the factor is the reciprocal. So if I had sine of 2 theta inside the parentheses, then that's actually a dilation of 1/2, which makes it narrower or squished from the sides. And if it was like, let's say a 1/2 inside, so let's say it said sine 1/2 theta, now that's going to be a factor of 2 because it's the reciprocal, and that's going to stretch it out further. So we say that it's a factor of 1 over the absolute value of b. You don't have to worry about a sign on b. And the period is changed by the factor of that value, 1 over b. If you're looking for the actual period, you can find it by doing 2 pi over b. Okay, so an example here, graph y equals cosine of 2 theta and describe the horizontal dilation. So we know because it's inside the parentheses, it is a horizontal dilation, and it's a horizontal dilation by a factor of 1/2, which basically takes your period, which was normally 2 pi, and it cuts it into half. Okay, you can either look at it that way. I could take 2 pi and multiply it times a half, or I can say b is 2, so I can do 2 pi over b, which is 2, and I get pi. So whether we do 2 pi times the factor, a half, I get pi, or I do 2 pi over b, both times I know that my period is pi. So here's where it gets a little trickier. That means that from start to finish, my entire curve fits in half the length. So now if we want an exact key point, we have to figure out what the halfway mark is and what the quarter points are. The halfway here is easy. Halfway between 0 and pi is pi over 2. But then we got to figure out the quarter. So a quarter of pi is pi over 4. And 3/4, or halfway between pi over 2 and pi, would be 3 pi over 4. So if you took your period and you multiplied it times a fourth, a half, and 3/4, that's how we did it last year. When there's a period change, that's one way to do it. Now our amplitude is still 1, and this is cosine. So we start at the amplitude, we come down to 0, negative amplitude up to 0, and back up to the positive amplitude. So if I was to overlap this with my original parent function, that whole curve would be taking place in half the distance or the width of our original one. So it would happen twice within one frame of our original parent function. All right, now this one's got multiple parts. So let's identify each part. The negative on the front means this is a reflection over the y-axis. Nope, sorry, over the x-axis. Or it's upside down. The 5 means your amplitude is 5. It's a vertical dilation by a factor of 5. B is 1, so I know my period is our normal period, which is 2 pi. And because there's something added or subtracted inside the parentheses, there is a phase shift or a horizontal shift. Opposite direction, so if it's positive pi, it's actually moving it left pi. If there was something added or subtracted, there'd be a vertical shift, but that's not happening this time. Okay, so now let's think about all these changes. I know this is going to flip in my opposite direction. So where sine normally goes 0, up, down, up, or downtown, up, now it's going 0, down to -5, up to 0, up to +5, and back down to 0. So that took care of my reflection, My amplitude, the only thing I haven't done is my phase shift. So everything's moving left pi. That means my first point shifted to negative pi. So that one's gone. It means at positive pi over 2, it would be shifted back to negative pi over 2. So that one's gone. It means pi got shifted back to 0. So that one's gone. It means the 3 pi over 2 should be happening at pi over 2. And it means the 2 pi should be happening at pi. So everything, all those key points we just subtracted pi from. And then there's my curve. Reflected over the x-axis, amplitude of 5 or a vertical dilation of a factor of 5, a phase shift negative pi. Okay, example 6 says write the sine function with the given transformation. So now we're doing like what we did in 3.5 where we're getting information and we're finding the equation. This one says it has a phase shift to the right, pi units, an amplitude of 3, and a reflection over the x-axis. So the phase shift is going to be added or subtracted inside the parentheses because it's right. We're going to subtract it. The amplitude is going to go on the front of the trig function, and then the reflection is going to also go on the front there. So we're going to do f of x equals, the negative comes first, 3 for the amplitude, sine of, and it'd be theta minus pi. And then there's the equation of your function. Example 7 says, identify the transformations of the given sine function and then find the equation of the function. So the goal here is to identify any kind of phase shift, any kind of change in the period, any kind of change in amplitude or direction. So if I look at the first one, it starts up, it comes down, it goes back up again. And this says it's a sine function. Typically, sine starts at the axis, goes up, comes back down again, and goes back up again. So already we see that there's a phase shift. Everything started at 1.5 here. Then you want to see that you have a amplitude of 2.5. And our period goes from 1.5 to 3.5. So the period is 2. So when I plug it into the equation, I get f of x equals amplitude 2.5 sine. Now my period has to get shifted. So the period being 2, if I want to find b, remember 2 pi over b equals the period. So if 2 pi over b equals 2, and I want to solve for b, I can cross multiply. 2b equals 2 pi, divide by 2, and b is pi. So the b is pi times theta, with my phase shift being to the right, which it could go either way, but we're going to say it's going to the right, 1.5, so this would be a minus 1.5. So first part, amplitude, b affects your period, 2 pi over that would be your period, and then inside the parentheses would be your horizontal shift or your phase shift, and again it's to the right 1.5, so we subtract 1.5. Last example here, notice my midline shifted up, so I know this has a shift up and we're at 1, so it's a shift up 1 or a vertical shift up 1. Now my sine curve starts here, it comes down, goes up, and finishes out here. That's upside down, so I know there's a reflection. And it stops here, which is just past 3. Since that typically would be a 3.14, we're going to say that our period is pi. And our amplitude from 1 to -2 would be 3. From 1 to +4 would be 3. So our amplitude is 3. So f of x would equal, the amplitude is 3, but it's negative because it's upside down. Sine, there's no phase shift, but there is a b, right? We said our period was pi. So if 2 pi over b equals pi, I cross multiply, so pi b equals 2 pi, divide by pi, and b is 2. So I get 2 theta, and our shift up 1 means +1. And there's the equation of this function. Okay, that wraps up today's notes. Make sure you submit your notes before the end of class. And you can use the remaining time to work on your 3.6 homework. Have a great day, guys.